Welcome again, everyone, to our roundtable. I want to thank many of our organizers at MIT and Harvard who are working tirelessly on many aspects of decentralized AI research and also looking at how many of these ideas can be brought in the real world. We're also joined by some eminent discussants who work at the intersection of AI and Web3. We'll be hearing more from Steve Dzerzhinsky, Medha Parlikar, and Praneeth, who formerly from MIT is now a professor at Abu Dhabi. So let me talk a little bit about this concept of God AI. And I know theoretically you'll figure out I don't mean God in the religious sense, but there's a particular meaning to it. So what is God AI? So, a long time ago, I was at Burning Man and I saw this booth that says talk to God, a telephone booth. So would you go and pick up this phone and talk to God? Well, if that year, if you had picked up the phone, the voice of God on the other side had a thick Indian accent, and that was me. And so for several days, I heard from fellow Americans talk about their ambitions, but often their frustrations and their deep, challenges. And somehow they thought this God on the other side of the call can solve their problem. And that was a very moving experience for me, just as a human being, to hear all these, challenges and frustrations people face in their life. But as a scientist, I was trying to figure out why would people share their deep, dark secrets with me and expect me to solve them without knowing me well at all. And I think the point there is many of us really hope to have somebody who's out there who is impartial, honest broker for our whole world. And when I came back to MIT, I said, maybe that's what I need to do. We need to create a newfangled AI that will behave like a trusted, honest, impartial broker. So is that what decentralized AI is all about? So we already have a god of traffic, which is Google Maps. And anytime you want to go from point A to point B, even if you have been on that road before, you open up Google Maps because you're curious about where is everybody else on the road. Because it doesn't matter how smart you are, how good a car you have, how good a driver you are. The only thing that matters is where is everybody else. And in a very decentralized manner, all of us willingly give away our GPS location. Google analyzes that traffic density, and then for each of us, it beams a highly personalized turn-by-turn navigation. And in a way, that's what we imagine an omnipresent, omnipotent entity to do for us. Have this God's eye view into everything that's going on, and then guide each of us to do what's right, but also guide the people with whom we are in conflict or we would like to collaborate and nudge them as well, so that globally, we become better. So we have gods for traffic, but we give away our GPS location, which we think is a low stakes, information willingly for free. But that's going to be true in everything else, right? So this public versus not so public information is the current challenge in AI. If you think about platforms like ChatGPT, they look at everything that's surface web, anything that can be accessed without login and password. So books and Wikipedia and news articles and so on. But the role of decentralized AI is to look at what's submerged, this deep web, not dark web, just the deep web, where data may be siloed or wisdom is actually captured in simulations and not in raw data. So think about financial simulations, think about autonomous vehicles, think about clinical trials. All the simulations is the wisdom out there. So it's not just raw data. So in the world, GDP is about $100 trillion. And a lot of that happens in the physical, in the real world. And if we really have to take AI into the real world, we at MIT think that we need to make progress in all three areas. First is decentralized AI, which we're going to talk about, working across siloed data and governance and multimodal interactions. But there's also dimensional AI, going beyond screen AI, which is where a lot of DAO, which is where a lot of cryptocurrencies, which is a lot of productivity tools or charts and summarization bots are, but go into dimensional world, ports, mining, agriculture, and so on. And then finally, the notion of discoverable AI, which is right now, if you think of any ecosystem experience, think about health, you as an individual, as a consumer, has to go and connect all the entities, your doctors, your pharmacies, healthcare, insurance, all of that. But we want discoverable AI. So very briefly, I'll talk about these aspects. And as Chris Dixon at A16Z in his recent book talks about, today's systems are deployed by corporations. So if you think about Amazon or Uber, they have a very open secret, which is, attract and then extract. They bring lots of players on their platform, and then they extract their values and they lock them in their walled garden, which works great. But we think most of the world is moving more towards protocol networks. And India is a great example with identity systems, payment systems, and emerging e-commerce systems, where it's based on open protocols. And a lot of the value is going to be accrued because of the data and the users and the ecosystems that run these protocol networks. And those of us who work in Web3 know the power of protocol networks really well. All right. There are two major trends that are going to make decentralized AI something that we really care about. First is the notion that the compute is moving from big mainframes and server farms to our edges. And this edge AI is compute because it's important because companies like Intel and HP that we'll talk later today are really pushing this idea of an AI PC that has not only a CPU and a GPU, but also an NPU, neural processing unit that's highly optimized for AI operations. And if you think about how AI is delivered today, everything is centralized. The data is centralized, the compute is centralized, talent is centralized, but even the governance is centralized. And that's just unsustainable. And this is, by the way, how internet was run in the 80s and 90s. We had IBM mainframes and Cray supercomputers and DEC. A lot of the companies right here on Route 128 thought the way computer revolution is going to work is massive mainframes, and the users, consumers like us, would have a WAN terminal with 28 kbps modem, and we would interact with these mainframes with this really dumb terminal in our offices and our homes. By the way, how did that play out? It didn't work out really well, because the moment PCs and laptops started becoming available at a lower cost in the 80s and 90s, most of the mainframe compute companies disappeared. And that's one of the losses for Boston, by the way, Boston ecosystem as well. And the same thing would happen now. Right now, we have a dumb browser through which we interact with all the AI services right now. Whether you connect to ChatGPT or Gemini, we have a dumb browser. But that's not with the future. The future is we will have AI models running on our own machines, trained, but definitely for inference. So as the power shifts to the edge, decentralization will start going to play a very big role, the same way it did in the internet era in the 90s. The second big revolution that's happening is each of us is going to have our own personal agent. There'll be 8 personal agents for each of us, a digital twin, but every organization, every company, every city, every town will have its own agent that's interacting with us. And because it's happening at the edges, they don't really have to worry about the compute cost as much as we would do today. So the intersection of these two trends is really driving the decentralization. So if you think about AI today, AI behaves more like an assistant or a librarian. But very soon, AI will behave more like an engineer, and then AI as a scientist, right? So I'm not going to talk about the centralized aspects of this is happening, such as autonomous vehicles and so on. A lot of centralization will continue, and that's great in those platforms. But for decentralized, in sectors like supply chain and e-commerce and shopping and healthcare and finance, the top row is where we're going to look at. So I'm just going to show 2 very quick examples. One, a shopping AI copilot, and one in healthcare. And the challenge to go from AI as an assistant to AI as an engineer is that engineer AI needs access to a simulation, ability to compute functions and have a crystal ball and what can happen going forward if you have a really good simulation and reality match, a good enough simulator. And but to AI to behave like a scientist, we'll have to care about scenarios where the simulation will not be good enough. So consumer behaviors, or how proteins will and different drugs will interact with certain disease conditions. the gap between simulation and reality is very large. And that's where AI as a scientist really becomes very exciting. So let me walk you through these two top examples on decentralization for AI as an engineer and AI as a scientist. So, birthdays, my daughter's birthday is coming up next month. And who here likes to plan a themed birthday party for your loved one? And how many people get stressed out? Okay, I get totally stressed out. And the reason for that is to do this themed birthday party, have to go to some big box store and come up with a plan in my head and constantly worry about, is this really one my daughter is going to be excited about? And figure out all the plan and still make sure it's within my budget. What would really get great is if I can, let's say I'm a Target, I can just talk to my Target AI and say, Target AI, my daughter's birthday is coming up next week. Can you tell me what I should do? And what Target AI should do is, go into my photo roll, figure out whether my daughter is more into Taylor Swift or more into Star Wars. Also access the photo rolls of all my friends to whose birthday parties my daughter has gone to, and look at what are the most recent trends that she's into, and then go and talk to all its vendors to see, because if Target starts suggesting Star Wars theme to everybody, they may not have enough inventory from their vendors. But the vendors are not willing to share real-time status anyway with Target. So they have to go and query all their vendors of what's available in the next 3 to 4 days. And then it can do the query and come back to me and then figure out, and Target already has a 3D model of my interior of my house and my backyard. And through Gen AI, I can just have a simple augmented reality experience where I can see a video of my daughter playing with her friends with one of the chosen themes, let's say Star Wars theme, and just gives me 3 options, $200, $500, $1,000. And I can just click one of them and all the supplies get delivered to my house in 3 days. But the whole interaction that I described to you online happens in a matter of 10 seconds. So I think this is what we mean by decentralization playing a role in discoverable AI, where we can discover entities and vendors and experiences, for what we want, because what we hate is when organizations try to sell us products. And what we want is they should buy our need. If my need is to organize a themed birthday party for my daughter, they just need to buy my need and ask what price I'm willing to buy this need for. And everything else should be automatically figured out in this highly decentralized ecosystem back there. Does it make sense? Excellent. All right. So that's one example of decentralized AI. Let me show you another one. And as I said, the interesting part about how AI is going to emerge, and many of us are worried about, there's simple AI, there's emergent AI, and there's a kind of a super intelligent AI. And the way that's evolving in mind of most people is a highly centralized version where we'll buy a bunch of A100s and H100s and X100s over time, spend billions of dollars and train this intelligence magically on these platforms. But that's not how the real world works. In the real world, we all get smarter by interacting with each other. And the same thing is going to happen in AI as well, where agents are going to network with each other. All of our digital twins are going to network with each other in the beginning with very simple agents. And over time, they become smarter and smarter, right? Because even in a company today, the CEO is not the smartest person, but the CEO becomes smarter by working with their whole team. And they might have thousands, maybe hundreds of thousands of employees, but the organizations become smarter without worrying about an individual being the smartest in that entity. And the same thing is going to happen for AI, where we have highly decentralized multiple agents, each of them smart on their own, but overall ecosystem can have super intelligence. So we think the emergent and super intelligence is going to happen through networked agents as opposed to highly centralized approaches that everybody's going after. And again, the example we heard from Cray supercomputers from 80s and 90s, is something to keep in mind. What is more, if you go back in time, what's more important for computing revolution, the computer or the internet? And one would argue that the internet revolution is much bigger than the computer revolution, because once we got connected, we have this tremendous impact on $100 trillion of world GDP. And the same thing is true today. What is more important, an AI, an intelligent machine, or intelligent machine that's connected through decentralization? And we, of course, believe that decentralized internet machines, intelligent machines, is what really matters. So that's why decentralization is so key. So what can we use it for? Imagine Sarah in Texas has a chest pain. She recently had COVID. She has family history of lung cancer, and she's just not getting good guidance from rural doctors in Texas. So imagine one of those doctors can just go online on this decentralized AI healthcare platform and say, hey, for $10, can somebody give me the best answer for Sarah? These are her radiology lab, these are her pathology labs, this is her history. For $10, please somebody give me the best answer. So, if you had God's eye view, we could solve it. John, the doctor, can look at all the health data that's available in the world, especially relevant to chest pain, train the best machine learning model that could cost a few $1 million with this petabytes of data, reward the contributors whose data was used and whose compute was used. There's only $10. It's not much to split. And then come back with a highly interpretable experience for Sarah that says, what's an aggressive treatment, what could be a treatment where she doesn't have to travel to Houston, and so on. Very much like you would get an experience on Expedia, where cheaper flights versus expensive flights versus nonstop flights and so on, you can choose what you would like to do on this flight. So if you have God's eye view, we can actually solve majority of healthcare overnight. Just think about that. We can solve it overnight for conditions we understand. Of course, the reality is that we cannot look at all the data because of privacy and regulation and trade secrets. We cannot train the best machine learning model because it's too expensive. What does it even mean to train remotely? When a hospital in the Philippines or Algiers is going to help us in this condition, and what does it mean to choose the best model? And then how do you take this $10 and start rewarding all these folks? That's not much money, because there are also a lot of invisible efforts. So hope is that it's not just John in Texas who's querying, maybe millions of others are also querying for $10 each. So at any moment, maybe tens of millions of dollars are being bet on this global hive to see if somebody can give the right answer. And we have to take these tens of millions of dollars that are emerging to see if there's some pre-trained models, if there's pre-sorted data, so that you don't have to start from scratch, but you just do the incremental work that you have to do based on what was done before, right? So even the $10 contribution from Dr. John can actually start adding to this pool, right? And then finally, we need this amazing user experience. Google Maps is a great tool of a crowd UX. It doesn't just show you the route, but shows you where everybody else is, and collectively as a group, how can we go from point A to point B in the most efficient manner? It's kind of an interesting crowd user experience. So we need something similar for Sarah as well. And that's what we need. We need a global orchestration of decentralized AI, which is the God AI. And the good news, as we showed in the video, is that many components of this have already been tried out in the Web3 world. Some of that unfortunately, from sort of scammy purposes, the cryptocurrencies and decentralized finance, but the building blocks are beautiful. They're based on distributed computing, based on cryptography, based on game theory, and so on. And all those components are extremely valuable. And if you can upgrade them, will be amazing. So let me go through these 4 upgrades we would need for Web3 components to make them compatible for decentralized AI. And this is a lot of the work our team at MIT and many of our collaborators, many of the startups and many of the corporations we're working with are working. So first one is going from the pseudo-anonymity that you see on Web3 to something we call a no-peek privacy, complete anonymity and complete privacy. And as I said, Google Maps, we have no sense of privacy. We give away our GPS location to Google, get great utility in return of traffic density. On the other hand, if you take an example of healthcare, then we worry too much about privacy, which we should. And because of that, we get very low utility. We don't get, even if we have the journeys of all the patients, we cannot analyze them to create the best treatment plan for a patient like Sarah. So just think about that. If we can somehow aggregate that, we can solve this. And so few techniques have emerged. So anonymity and confidentiality and consent is not privacy at all. So just ignore all of them. You know, so GDPR, CCPA is not privacy. It's just confidentiality. Other techniques like differential privacy can allow you to obfuscate, but in that case, your utility starts going down. Maybe you can infer, maybe you can do statistics, and then of course you can do techniques like homomorphic encryption, but then you can do mainly statistics and less than, greater than, equal, and so on. You cannot do full-fledged machine learning models in a very efficient manner. So two techniques have emerged. One is one is federated learning that some of you may know from Google, and the other one is called split learning from our group here at MIT. And here the idea is to smash the data to create a privacy-preserving machine learning. So the key idea behind both these techniques is to share wisdom without sharing raw data. Okay, and that's how no-peak privacy can be built. And split learning and federated learning are still not as compatible with what we need in decentralized AI, because if you have a 400 billion parameter, Llama 3 model, it's not going to fit on your phone or any edge device. So what does it mean to do decentralized AI when the edge devices have not enough compute, maybe of the order of a few gigabytes, but not hundreds of gigabytes? So we need a completely new version of split learning and federated learning. The next one is verifiable decentralized AI. And some of the techniques that you see in ledger technologies such as blockchain, can be upgraded. So the fact that you have to show a proof that you have trained a model on certain amounts of data, that you can verify that the model that's being served is the model that was trained, also show that the model I'm using is the best one, not the one you trained 5 days ago, but a fresh and the one that I really care about. And then when all the queries start coming around. So in blockchain world, hashing, proofs, consensus, and publishing on a chain are very well studied. And the same concepts had to be achieved in the AI and machine learning world as well. So some really exciting directions in this space. The third one is data market. Remember, Dr. John is just willing to pay $10 to acquire data from Philippines and Algiers and many other places. And clearly, the hospital in Philippines doesn't want to just send the raw data to Texas, because once it's copied by John's hospital, it could leak out, and the Filipino hospital will never make any more money. So how can you send dollars to hospitals in Philippines without copying their data and learning wisdom from their data without asking for copying their raw data? And so there's a technique that our group and others have built called data markets, which is how do you estimate the dollar value of invisible data? And the basic concept here is you're going to send some cryptographic puzzles, some projections, some correlations of the data, and just based on that projection, of low dimensional projection, you can compute what's the value of the data of this hospital in Philippines. Okay. Again, a fantastic area of research, and hopefully we'll see a lot of startup activity in this space. And then finally, crowd UX. So if you cannot look at data, how can you do orchestration? How can you even discover that the hospital in Algiers versus the hospital in Manila have the kind of data you care about? Are there going to be global registries? Are there going to be global updates? And so on. How do we actually create decision support for all the systems? So if you look at, being on Fidelity or your favorite exchange for transaction, a lot of these problems are solved of discovery, decision support, recommendation, projections, future predictions, and so on. And all these things have to come together for a decentralized AI exchange as well. Of course, there are benefits for decentralization. Everybody knows innovation can happen faster at edges. Plurality leads to more responsible AI because governance is distributed. But there are many risks because any algorithmic social orchestration can have catastrophic failures, like we saw with Terra and Luna and so on. And of course, we have to figure out how bad actors are not behaving in an adversarial manner. I mean, they will behave in an adversarial manner, but they cannot introduce adversarial activities. And then, of course, this is not about just healthcare or finance or shopping. If you have this decentralization, you can map that to many other sectors of the $100 trillion of world GDP. Whether it's climate, whether it's science, there's a big movement in decentralized science where you can go from information to wisdoms, to drugs, to clinical trials, to change in protocol using complete decentralization. There's philanthropy. Right now, about $500 billion of in today, about $500 billion is given away in philanthropy in US alone. But there's no telemetry built in, there's no incentivization built in, there's no reputation built in, and so on. It's happening in the physical world. There's sports, there's refugees, there's a lot of societal problems. And I would say anytime there is a two-sided or multi-sided marketplace, ideas from Web3 and decentralized AI can be deployed. So I think next time you go to Burning Man, instead of talk to God, you should really say talk to gods. And this concept actually comes to me very naturally. I grew up in India. We have not a single god. We have 330 million gods, one for every aspect of your life. Unfortunately, there's not one for AI, but there's one for intelligence, Ganesha. So I think, even, ancient cultures figured out how to decentralize, your experience with God. I think it's really time for us to think about how to be decentralized, at least AI. Thank you. So let's take a couple of questions before we bring on some of the folks. Are there questions online? Yes, go ahead.
I got one. How do you think about people basically acting maliciously when it comes to data? I know you mentioned that you have to watch out for bad actors, but if you introduce some sort of incentive structure for data, let's say that hospital in the Philippines, if it's a peer-to-peer network, everyone can see the communication on the network. So if I wanted to fake that I have health data, what stops me from stealing basically their answers and playing it back slightly edited, so that you think I have actual health data when in fact I'm just a random hacker on the internet?
Yes. I think that's the bad actors and free riders are a very critical aspect of it. Even if they're not adversarial, they're not malicious attackers, you're going to have a lot of bad actors and free riders. So that's a very important concept of this. And when you talk about ideas like data market, like you said, you want data that's relevant and has some diversity, but it's not too diverse. If I'm looking for X-ray data, don't sell me ultrasounds, even if it's for the same health condition and so on. So you have to build in all of that as part of your statistical, as part of your machine learning machinery, so that you can say, hey, without looking at your data, Philippines in Manila, I'm going to send you this cryptographic puzzle. You have to solve it, and I'm going to send actually not one puzzle, but I'm going to send you 10 different puzzles, and you send me the answers because I can't reveal to you what I'm interested in. So I'm going to send you 10 different cryptographic puzzles, and when the answers come back, I'm going to throw away the 9 of them. I'm going to use one of them to see it matches what I care about. And so we have a lot of research. Others are working on this notion of relevance and diversity of the data, in addition to, of course, the quality of the data. So it's a very important, and that's why I think a lot of ideas in Web3 have to move on to decentralized AI, because in Web3 it's pseudo-anonymity, but everything is visible on the chain. And here, you cannot look at the raw information at all. You cannot look at the raw models. You cannot look at the raw data. You cannot reveal your intentions. The fact that certain hospital in rural Texas is querying for a particular disease itself is, privacy. So all of this has to be sustained in this machine learning framework.
We have a few questions online. Do you want to take them up?
Yes, please.
So I'll start with the one on agents. So the question is, how would decentralized AI and compute go hand in hand? Any specific agentic systems that can communicate among cross-domain agents to pass intelligence? So basically the idea of agent interaction and decentralized AI.
Yeah. These are still very early days for agents. And actually, Abhishek, you can take this question because it's part of your research as well. This notion that, just to find the collaborators, who do we work with without telling each other? It's very much like how you would behave here in Cambridge. When you meet somebody, it takes some time to figure out whether you want to become friends with them, whether you want to collaborate with them, and so on. And then the reciprocatory interactions that go on, where you selectively reveal more about yourself to the other party to figure out whether they should be collaborators. And even when you're collaborators, you keep a certain wall. But Abhishek, want to take that one?
Totally, yeah. So building upon what you just said, right? So I always give this example. The reason internet is so successful is because we have exabytes or probably even more amount of data. But at any given point of time, all you need is a very small chunk of it, usually in kilobytes. And we have this whole infrastructure of domain name mapping, search engine recommendation, and so on that boils down whatever we need. And doing same for at the layer of intelligence is what allow people to contribute lots of data, create this huge pool of different forms of intelligence, but at the same time, be able to get what you want. And that's where the idea of who should I talk to, what information should I get, would become very important and relevant.
Fantastic. I see Ganesha is here. Why don't we start with Ganesha? And we'll have a little bit of more time during the Q&A. So let me have a pleasure of introducing Ganesha Rasia, who's the Chief Strategy Officer at HP, thinking about AI PC, thinking about NPUs, and how really we think about this compute going forward. And I have really enjoyed brainstorming many of these concepts with Ganesha, who works very closely with the leadership team at HP. So Ganesha, go ahead.
Thank you, Ramesh, and thanks, everyone. Just great to be here and great to be part of what I think is a very lively and very important, very relevant conversation. I'll just spend a couple of minutes talking about how we think about AI in the context of decentralized AI, which I think is the topic du jour. The way we look at the world is, we believe in the construct of decentralized AI. Firstly, because we see the decentralization of compute. We see the world as hybrid between what exists in the cloud, what exists in data centers, and what exists in the endpoint. And there will always be this, I'll call it sharing of compute and decentralization of compute. Now, orchestrating that with software applications and AI and how much, where do foundational models sit, and how much do, large language models get segmented into what now fits in an endpoint, are important conversations that we tend to have inside the company. Naturally, NPUs and GPUs are now very much part of the architecture within the endpoint, and we've seen very real performance improvements and performance differentials between how NPUs process AI workloads versus GPUs versus certainly the CPUs, which are really not built for this. The comment I would make also is around decentralization is that I think it's less about centralized versus decentralized. I think it's how decentralized will it be, and that's really the discussion. Because in the world of enterprise applications, if you look at what Apple has announced on AI intelligence or what Microsoft's been doing in Microsoft and Copilot world, you can tell that there are domains within which these agents operate. But in reality, there needs to be multiple agents, and there's a level of decentralization across different applications. Now, there are control points. There are important considerations for some of these SaaS providers and how much control they're willing to give up through access to their data. It goes back to the data conversation. So I think the world is still shaping itself in many ways between large software providers, hardware providers, and certainly the startup community that's moving at rapid speed. And within that, there's a construct of the foundation model builders. There are and it's a never-ending arms race with even if you see what Llama 3.1 now looks like, it's pretty incredible. And then there's orchestration above that, and then there's personal agents. So I think I cannot see a world, and we don't really see a world in which AI is truly centralized. It stifles innovation, among other things, and it's ultimately not going to be great for the end customer. But how decentralized it is, and how do you then manage for all the elements of bad actors and all the risks that we are identified, is going to be interesting. So those are my sort of opening remarks, Ramesh.
Fantastic. I'm going to invite Medha Pardikar as well, just to join this panel conversation. So Ganesh, if I can ask you a few questions to get started. So I agree with you that it's not pure centralization, pure decentralization. We cannot be maximalist and all that. when I talk to my friends at Qualcomm, they talk about, kind of the edge and the near edge and the far edge, and then the server. How are you thinking about at HP about this transition from where you probably get revenues from, server farms as well as PCs? What's going to be in between, especially as we start thinking about 5G and 6G, but there's going to be this, nodes and super nodes along the way for compute.
Yeah, and a little bit of historical context. As of 2015, we've separated our businesses between the data center business and the endpoint business. So HP Inc. is the endpoint business, and then HPE has the data center piece and also networking. I think when we think about monetization, we see it in several forms. So for one, we see a significant demand increase for an AI PC as an example, which means an endpoint that is able to compute and able to run not large language models, but certainly smaller language models and iterations thereof. The power of having an NPU at the endpoint is that it actually allows for local inferencing. And suddenly I tend to say this quite a bit. If you think about the world of SaaS, this world of SaaS is a powerful model for delivering outcomes and in a recurring sort of way and a lifecycle model for customer. But the world of SaaS for enterprise or a company is that it provides for scaling and a level of, I'll call it lowest common denominator. And in other words, this is what happens with CrowdStrike, right? And when change happens, everybody gets hit. And that's the world in which we live in the SaaS world. However, if you think about what AI can do, it can drive a level of personalization into SaaS that previously didn't exist. So that, how I experience, Adobe versus how somebody else experiences Adobe could be very different. And so that's the world, I think, I tend to think of the world as somewhat cyclical. We go from, standardization to personalization, from, scale in the center to, distributed scale. So I think for us, when we look at monetization models, we see it in the context of, advanced compute capability. We have a portfolio that also has data scientists working on some very advanced modeling and actually model calibration, pulling it from the cloud and calibration work, in addition to the AI PC, which is a different endpoint productivity tool. In addition to that, we also see a lot of work. We're actually doing a lot of work around the employee experience. So specifically, how do you manage your fleet? How do you manage that overall experience? And how do you, in this new world where AI wars could be very much a thing that's forthcoming, how do we, use AI to manage AI, use AI to protect against bad AI? It's a whole different paradigm, and we're actively looking at that from a software perspective as well.
So, Ganesh, on that note, and I know you have been in this sector for a very long time with multiple hats. Earlier, I was giving an analogy of how the internet evolved and how mainframes companies, didn't see the trend in decentralization. Are there other trends you have seen from .com era or, from consumer devices or other sectors? Is there something we can learn from as we move from a centralized to a more decentralized AI?
Yeah, I think it's the point you made earlier, Ramesh, also around you talked about 5G and even 6G for that matter. Connectivity is this linkage that allows for this oscillation between where intelligence sits, in the core or the edge, in the central or the decentral. So I think the way I think about it in the context of corporations is the agility, right? And being able, recognizing that there are going to be applications that are going to demand a certain amount of compute that necessarily sit in the cloud for now. But that is only true for as long as the edge and the endpoints don't have enough compute to sustain some amount of that. Over time, that's going to catch up, and then you're going to have that transition. But then we'll transition back because it's a bit of an arms race. The more bandwidth you have, the greater application demand it's going to generate. But the linkage ends up becoming connectivity, among other things, and security and all of those things. And so bandwidth continues to increase even over wireless, which is pretty remarkable at the speed at which it's running today. So I think for me, the way I think about companies is that it's the ability to react and the ability to respond and recognizing the state in which whether it's centralized or decentralized. Today, we see the world as decentralized, but for the longest time, and it is still true, cloud growth continues to grow. Cloud growth continues to be a thing, right? And it's just slowed a little bit recently, but let's be real, that's going to pick back up. So this, so as much as we spend a lot of, capital in what's happening at the endpoint, and there's a lot of arguments around security and latency and all those things, so all legit. Latency will be corrected over time with bandwidth growth. Compute and security, you could argue the cloud is actually pretty secure given where it is today. So there's this push and pull will continue to happen. Is the way I think about it. So for me, back to for the earliest days, .com era and prior to that, I think it's agility that's going to ultimately matter. The speed at which the world is evolving is pretty remarkable. The one other comment I would make is, I think software companies play a very interesting role with this AI, with generative AI becoming a thing, in that their moat has changed dramatically. And so what they've done, if you notice, is that they have tried to play the decentralized game as far as what Microsoft's doing, what Google's doing, et cetera, Amazon's doing, Bedrock and all that. The idea is that we'll make any and all models available to whomever, and that's a sign that they are also like recognizing, rather than trying to play a specific game. Microsoft, for example, with Azure, they're saying we'll open it up. We'll have as many AI models out there for customers to choose depending on the application. So agility, in my mind, is the biggest thing in the tech game.
Fascinating. I'm going to invite our discussants, Steve and Medha, to join in. I'll just ask a question before that, which is, let's take the Google versus Microsoft mental view. Not just those companies, but just as a mental view. Google kind of has its dominance because it controls the browser experience, right? It doesn't control anything on your computer as such, as opposed to Microsoft, which owns our computer. So if you look at today, a kind of a consumer GPU, and let's use NVIDIA as a benchmark, in the kind of just in the it's about 1 teraflop of compute for a consumer GPU that we have it at home. If you look at H100s and A100s, they're in the petaflop range, which is not that much more. It's about 1,000, maybe 10,000 times faster than what we have at home right now. Now, if I look at Microsoft ecosystem, they are, we're expecting, companies like you and Dell and others are, last time I saw, we're about to expect to sell about 60 million AI PCs per year. And if I just play that out, that's about 300 million PCs in the next 5 years, right? And of course, the one that will come in a few years will be even more powerful. But the point is, Microsoft can literally outsource the compute to this 300 million PCs that are out there. And they may never have, in the extreme, have to run a cloud service at all, because they're effectively outsourced in a decentralized manner, everything about AI to the edge devices. On the other hand, companies like Google and others are stuck, having to build central machines because they don't own the computer, they only own the browser, right? And if I again use the analogy from the 80s, I remember I was in grad school and before that, and when we used the computers, the only thing we cared about is what's the resolution of my screen, because it was a dumb machine anyway at home. But obviously, once we got into more PC world and laptop world, we started thinking about, oh, maybe I can do image editing and video editing and I have VisiCalc and I have Document Maker. But then after that, we have, hey, I want my own security software. I need to buy a virus downloader, like a whole ecosystem. I basically had to become a CIO of my own computer at home, right? So if you take these two trends, kind of the Google mindset versus the Microsoft mindset, where Microsoft might outsource all of AI to the PCs that you guys sell, how's that going to play out going forward from decentralization versus centralization point of view?
Yeah, I think, to be honest, I don't see Microsoft doing what we just described, only because the world of Microsoft today is largely cloud driven, right? So Office 365, their model is basically to sell compute off of Azure. So that's their stated strategy. But let's assume for a minute, hypothetically, that was a decision that they were making. I think the scenario in which that would play out is that there's a point in which decomposing compute into that many different elements distributed across the country world can optimize for geography, etc. I mean, the recombination of that is non-trivial. It drives a level of resiliency and all that stuff. Those cases could be made in terms of being able to have protection, switching, and so on and so forth. But to decompose a AI workload into endpoints with such relatively lower compute capability, I think will create a pretty poor customer experience, just because the latency, not just latency of data transmission, but the latency of reassembly, and then traversing that from the compute layer all the way up into the application layer. Somebody's going to have to do that. I think that's going to be super challenging. Even today, with the AI models that we use and sort of tinker with, we see a stark contrast in terms of what's running on the edge, or what's running in a singular sort of frame versus one that's kind of distributed. So if you take that latency element and you distribute it now, one, there's a major risk, and then secondly, the reassembly part is, I think, non-trivial. So I don't know that I would argue for some amount of compute centralization or compute distribution, but not in the context of fraying it too broadly, because I think it's going to have profound implications at the application layer. On the Google side, I think Google's done some amazing work with Gemini and what they're focused on there. I think Google has big aspirations around what they want to do with Chrome OS and Android OS, and they have a lot of spaces in which, in the AI world, where that Android OS has become the platform of choice as far as a underlying kernel on top of which people are building AI applications. So I think it's going to be an interesting battle. I think it'll be interesting, and they will go head to head for sure.
All right, let me bring in Steve. Steve is a veteran in the Web3 world, including teaching classes here at MIT on blockchain. Steve, go ahead.
Yeah, sure. So I guess my perspective on this, I come from the Web3 world, the decentralized world, and we're working on some NSF-funded research right now where we're looking at how do you deploy the tools. And I should step back and say the world of Web3 and DAOs has done a bunch of years of experiments in trying to figure out this decentralized trust problem, right? So a lot of people, as Ramesh mentioned, cryptocurrency, we've got big hype, but if you take back the hype and you look at the tech that's underneath it, there's wonderful things like zero-knowledge proofs and multi-party compute and all this stuff that has been fleshed out in kind of a multi-billion-dollar system to kind of make sure that it's robust and it can't be hacked, or at least we know where the hacks happen. That background provides a great experimental set of data to look at and say what has worked and what hasn't worked in that space in terms of incentivizing people. Because ultimately, when you boil it all down, you get data and trust and privacy are kind of universal across a lot of these, finance and healthcare. So I should say the research we're working on, we're actually looking at use cases in regulated healthcare, regulated finance, water rights management, which is a very weird idea to kind of bring in organizations that are broader than just the corporation, but also bring in public externalities into the fray, like Ramesh mentioned around carbon credits, and then wastewater management too, which is a similar challenge where you're trying to have a community and have organizations manage that stuff. So ultimately, when you take a look at decentralized AI, and right now, of course, our research is focused on organizations and how you can run organizations more effectively, deploying these decentralized tools. But of course, it doesn't take long before you run right into all of the challenges of AI. So appreciate the invitation to come in and listen to this discussion. It's great.
All right, let me bring on Medha, who's also a Web3 AI expert, most recently a CTO at Casper. Go ahead, Medha.
Hi, Ramesh. Thanks so much for the invite. Can you guys hear me?
Yes.
Coming through good. Oh, okay, great. Yeah, so thinking, thanks to Steve kind of raising the issue or talking about the incentive mechanisms, right? And I feel that Web3 is really, really good around incentive design. I think that's probably it. It's not sexy and there's not a lot of hype around it, so you don't hear about it a whole lot. But what makes a lot of these networks function correctly and sustainably function for so long is that the participants, if they walk that blade edge of incentivization to do the right thing. And I feel that, with a lot of this data sharing, when you talk about federated data and you talk about data ownership, right? Just recently in the news, we heard about automobile manufacturers sharing customer driving patterns with insurance companies, and the FTC has told them that they need to be, has been alerted to investigate these guys because there's privacy rules around it, right? Like they can't just go off and monetize the data that way. So I think you're going to see a lot of even regulatory frameworks kind of crop up around the use of data, the legal use of data. And one of the things that Web3 is really interested about, and there's a lot of work that's being done on this, is like self-sovereign data. And this notion that individuals can own their own data, right? Own their browsing history, own and really have sovereignty around my health data, and as an example, right? And that actually, if you think about it, a lot of the regulatory issues will melt away once you solve the problem of individuals being able to own their data, individuals being able to participate in training these AI models with their own data, right? Then now I am granting consent, right? And then anonymizing that data. Web3 is really good about providing cryptographic proofs around anonymity and the provenance of that data. So I feel that, decentralized AI will absolutely need to use this Web3 backbone to help with federated data, incentive design and incentive mechanisms, right? And really kind of fine tuning the incentives to ensure that the system stays decentralized. And I don't feel that it's going to start off decentralized, right? I feel that decentralization is a process. And it's a process that takes many, many years to get to a place where you've got a robust system that is completely decentralized. It doesn't happen quickly. And I don't think it should happen quickly. I feel like, governance, when you talk about decisions, right, that kind of boils down to the governance around these distributed networks, right? And in terms of the edge computing, there's a lot of work being done in Web3 right now. It's called DePIN, decentralized physical infrastructure. And so there's a lot of exploratory work being done around training these AIs and breaking up that data, breaking up the models, and then trying to train and then reintegrate it. There's one protocol that's been particularly successful in a DePIN mode, and that's called the render network. So if you've not heard about render, they do image rendering. And so they shard the image and then they distribute the rendering efforts across many, many machines. And then you get the finished image back, right? That's what you get back from the DePIN network. So there's a lot of great research and a lot of capitalization of this research being done in Web3. So I'm really excited about what the future holds, both between decentralized physical infrastructure and how that's going to kind of merge with decentralized AI, right? To distribute these large workflows and bring people in, right? Bring people into the ecosystem, bring individual contributors in. So thanks, Ramesh, for the invitation. It's very exciting.
Fantastic. I think the point that Ganesh was making earlier as well, Medha, about the fraying. I think that's the phrase they use, Nisha.
Yeah.
Is empowering, but can also be very steep stabilizing. So Ganesh, we're going to switch to the next panel. But any closing thoughts on what Medha or Steve talked about?
No, I mean, look, this is a very fast evolving topic. So it's as much as we try to predict how the world will play out, it's it's playing out in a multitude of ways. So for every conversation around centralization, there's one around decentralization. I think it'll be interesting to see how it plays out. But ultimately, I think if you solve for the customer, usually technology kind of orients its way there eventually. So I think that's the closing comment I'd make. And thank you again, everyone, for the opportunity to be here.
Absolutely. And Susan is here from PhD at MIT, but also at AWS, very interested in decentralization. Susan, any thoughts?
Talk about put on the spot. I mean, I will echo Ganesha's comment on customer obsession. It is all about customer obsession. It is about, I mean, a lot of the concepts you were talking about, security and decentralization, resonate with us, especially if you think about how we've set up infrastructure.
Mhm.
It's all based on, not having access, right? You control what you need to do, and the operators should not be meddling. Like there's just different swim lanes, and we need to be very clear about that. The other piece is really thinking about explainability. We haven't talked much about that yet.
Yes, absolutely.
Talk more about that. 'Cause
If you look at the previous way with decentralization, let's call it crypto for lack of a good placeholder. I mean, companies like AWS sat out that wave, and companies like NVIDIA did jump on it.
Yeah.
And you had all these compute farms that emerge in different parts of the world. Do you think decentralized AI is something that is kind of coherent with how AWS would think about the world, or this is something that
I mean,
it's something
I'm
you ought to rethink?
me, so I don't speak to our global view on decentralization, but I will say that, our thinking about having data where you need it, when you need it, thinking about sovereignty, thinking about co-location of data with what you're trying to do, thinking about how to set all of those things up is absolutely in line with how we're thinking about. And even if you think about how microservices started or how some of the applications, the way we've thought about that from the get-go and the resiliency associated with that, I think there's quite a bit of resonance with what we've been talking about.
So the goal is more important than the process and the religion behind it.
I think so.
That's critical. Fantastic. Thank you, Susan. So let's thank all our panelists. Because we're going to transition to the startup panel now, which Abhishek Singh, researcher here at MIT, will take over. Just want to remind everybody about the program on decentralized AI, which focuses on multiple puzzle pieces of how we are stimulating decentralized AI from different research pillars. Medha talked about the incentive models, data sets, a gateway to broader ecosystem, of course, courses, many startups and entrepreneurship, various standards, events, and apply to become a research affiliate here as well. So with that, let me hand it over to Abhishek, and I know we'll probably run into the program. I just want to thank our organizers as well. So Abhishek Singh, who you'll hear from a minute, Shantanu Bhattacharya, who's a very well-known entrepreneur, has PhD and then MIT Sloan, sold his company to Facebook, has worked at telecom, infrastructure, and so on. Also visiting scientist at MIT, Rohan Khanna, who's our organizer here, Chris Pease and Cheng Yu are researchers in decentralized AI. So thank you all for organization.
Awesome. Let's start with the panel.
Yeah, we have a WhatsApp link if people want to join and ask any questions, as well as the Q&A that's going on the Zoom. So Abhishek Singh.
All right. Thank you so much, Ramesh. And it's a great pleasure to host this amazing panel. And we'll be hearing from 4 panelists. And all of them are doing great work in decentralized AI, and we will learn more about it. So to get started, we have Anna first. And Anna, if you are ready to share slides, please go ahead with it. And while she's loading the slides, the format is we'll hear for 5 minutes from each panelist first about what they're doing, what they're building. And then afterwards, I'll be moderating a panel and I'll be asking questions. And if the audience has questions, they can also write on Zoom. So go ahead, Anna.
Great. Okay. You can see my screen okay and hear me?
Yes.
Okay. Hey, everyone. Nice to meet you. I'm Anna. I'm actually one of Ramesh's former students. I met my co-founder back at MIT in one of Ramesh's great classes. And it's been a lot of fun to get to kind of pioneer this decentralized AI space over many years, and now really see kind of the world more broadly realize how important decentralization is to some of these technologies. So I'm going to be giving a quick overview of user-owned AI and kind of what that term means in a decentralized AI context. So today, there are kind of like two extremes of AI. One of them is centralized AI. So that's like OpenAI, Claude. Basically, you train a model, you keep the model weights private. It is good because it's monetizable, which is actually really important because AI is so expensive to build, right? It can cost $10 million, $100 million in compute and data to build some of these models. But it's bad because it's not controlled by many. And it really can become this arbiter of truth, right? So it's quite important that you have kind of broad input. And you also have this aspect of like, you get a lot of innovation from just making something open source and allowing anyone to contribute. And then you have the other extreme, which is open source AI. So that's like Llama, some of the open weight models, Mistral, Stability. One of the limitations is that it's not monetizable. And we've seen this where like 2 years ago, a bunch of venture funding went into open source AI and I think has had trouble really finding like sustainable models. But it's the good thing is it's controlled by many, so you get this open innovation. What we're building at Vana is kind of the best of both worlds, where you have user-owned AI that is monetizable and that's controlled by many. And the key to make this work is really privacy. So you need to be able to keep the data or the model weights private in order to truly kind of own something. And so, yeah, foundation models are really just becoming the source of truth and economic power. Whoever decides the data that goes into AI is basically deciding truth. We saw this example with Google Bard, where they added some filters on top of their model, where if you'd ask for a historically accurate depiction of a medieval king, they would give you like a Black man or an Indian woman, which just isn't grounded in truth. But if we didn't have another source, this would just become kind of the world's truth. AI models are really only as good as their training data. So if you've posted on Reddit, you've actually already probably helped train some of the leading AI models. This is GPT-3's training data. And this is related to the iceberg slide that Ramesh had earlier, where basically today we only train on public data because of the way that kind of systems are set up, maybe some private data that's purchased, but the vast majority of data, right, like less than 0.1% of the internet is publicly scrapable, is not included in these training data sets today. And so what we're running into is this kind of data wall in training AI models. So here are some of the recent models and how many tokens they're actually trained on. So Llama 3 was trained on around 15 trillion tokens. And what that means is, so the kind of common crawl is around 100 trillion tokens. If you dedupe it, it gets down to like 15 trillion tokens. So basically we run out of data to train on. Like if we're just using the public internet, we have no more data, but we need it. And so AI researchers are calling this kind of the data wall. Companies have realized like, hey, my data is really valuable. And so what they've started to do is really lock down their data and say, hey, I need to keep my data in because I want to make sure that I can monetize it. So you have like Reddit earning $200 million from selling data, PhotoBucket having people pay for data, Apple paying $50 million for data. And so kind of alongside this like rapidly closing internet, there's kind of this interesting fact where because of data regulation, users legally own all of their data. And so this fact kind of offers this opportunity where you could have 100 million users export their data from all these different silos and create a user-owned AI foundation model, which is what we're working on Vana, broadly kind of building tools for user-owned AI. And our guiding use case is this user-owned AI foundation model. You probably don't realize you own your data, right? So like you might not think of your Reddit data or your Twitter data or your Instagram data as yours, but legally it's entirely yours. You're just granting a very permissive license to the platform to use it when you use that platform. So as like an interesting exercise, I recommend like downloading your Alexa data. You'll hear like every single audio recording that I've ever taken of you. It's like a little bit creepy. The other one that's interesting is like you can download your Instagram data. They give you not just the data you've posted, but also AI labels they've put on you. One AI label they had put on me is stressed but not depressed. And there are like 300 other labels. So it's just an interesting exercise to kind of see. Just as a benchmark, like, do users have enough data? Broadly, yes. So like users have 30 times more data than some of the training data sets used for leading AI foundation models. And if properly incentivized, can create even more data, right? So you could end up with 5 quadrillion tokens if you're able to incentivize people to not just contribute their existing data, but actually generate new data through recording and stuff like that. Of course, like AI models also require a lot of compute. And so some kind of benchmarks here on basically, hey, do users have enough compute, right? Everyone's training a little piece of the model that they contribute back to the system. If you look at Ethereum miners, they have like 50 times more compute than some of the data centers used to train like GPT-4, other frontier models. And then once you have that user-owned AI foundation model, you have this really nice kind of collective governance and ownership. And so the collective can set usage rules, like who's allowed to access the model, what should censorship be like, who should get paid as the model is used. To one question someone asked earlier on kind of like data quality, one of the pieces of Vana that's really important here is called proof of contribution, where when someone contributes their data, the system basically measures how valuable is this data point towards this AI model. And so you can basically tie that back. And if someone contributed more valuable data, they get rewarded more. And so, yeah, in summary, foundation models, they really tend towards monopolies, but they don't have to. And kind of there's this other option, which is user-owned AI, where you can both build better models because you have access to more data and access to a broader collective, and also align them more towards kind of like social incentives. Yeah, Vana's building user-owned AI through user-owned data. The 2 key concepts are non-custodial data. So this means you can like own your data, permission your data without giving up control. The reason why this is really important is that companies don't necessarily want you to own your data. And so you actually need to exercise your legal right to your data. This came up with the Reddit Data DAO, which was one of the projects that launched on Vana. Reddit actually tried to shut this project down around when it hit around about 100,000 users. But because of the non-custodial data, where it's actually a user directly accessing their data and contributing it to the Data DAO sort of collective, data regulation kind of supported it continuing as a project. And they now trained a user-owned AI model. It's not a frontier foundation model. It is probably the world's best model at like shitposting. But they've got the model live, and what that allows for is this really interesting new paradigm of collective ownership of these technologies. This is kind of a quick technical overview of Vana. Feel free to go to vana.org and kind of look at some of our docs to go deeper. And maybe we can talk about some of the architecture as part of the panel too. And then, yeah, broadly kind of get involved with user-owned AI. Start a data DAO. Vana is a peer-to-peer network similar to Bitcoin or Ethereum. So you can run a node. It is entirely open source and kind of run by the community.
Awesome, great presentation. Lots of questions, and I'm sure audience will also have it. So we'll do it during the panelist session. And next we have, I believe, Richard.
Okay.
So
I can
quick
share
story
screen.
before Richard, while you're loading the slides. We met during NeurIPS 2022 during a Decentralized AI workshop at NeurIPS conference. And I believe there was only like around 10 people attending that workshop, even though total number of attendees at the conference was probably in thousands. And since then, the community has grown so big. And it was very interesting to see how like small community, but same ideas has been now going out in the ripples. So excited to have you here, Rich. Please go ahead.
Thanks. Yeah. I'm having trouble sharing my screen. I wonder if I could just share quickly with you.
Yes, and I believe Chris and Rohan, we should have the slide decks, right?
I don't think you have mine.
Oh.
Here you go.
Perfect. Okay, let me share my screen.
Sweet.
Do you see it?
Yeah, perfect. Sorry about that. Okay. Yeah, maybe you'll have to move the slides as I'm ready as well.
Okay,
Yeah. So thanks for the intro. Yeah, I'm Richard. I'm from NAPTA AI. My previous startup is Algovera. So that's, I think, what you saw on the slides. But NAPTA is a new startup, and we just, successfully fundraised as well. So what we're working on is a decentralized orchestration for multi-agent systems. So if you can go to the next slide. Yeah, so just a quick bit of my personal background. I did a PhD in engineering, then a couple of postdocs in ML. I worked as a machine learning engineer at Huawei and Xperi in like generative AI type stuff. And then I quit my job to work in decentralized AI just over 3 years ago. So some of the stuff that I've been focusing on for 3 years is, how can we deploy AI applications on decentralized infrastructure? And also, apart from the ethical point of view, which, I really resonate with in terms of decentralizing AI, I think it's important to, find places where decentralized AI can be more performant than centralized AI. So next slide. So yeah, there's a bunch of different approaches to decentralized AI. A lot of people are trying to, decentralize model training. I think that's like super valuable. Also, like some people are working on decentralization of model inference. There's kind of a third kind that we're most interested in, which is decentralization of application platforms. So what's the difference between an app and a model? Or what's the difference between an agent and a model? An agent uses a model as one of its components, but it also has a bunch of other components like a database, or it can use tools, or simulators sometimes, or lots of all of these things. So agents are kind of like a higher level version that use models, but they also use other components. And that's where we think decentralization can really be beneficial by exploring these systems of agents. So next slide. So we're starting to see, a bunch of systems of LLM agents. People might be familiar with Baby AGI. This was one of the first ones. That was for, using different specialized agents for solving tasks. We've also seen like coding agents like MetaGPT. That's in the bottom left, you'll see the image where they have different specializations like product manager and architect and project manager. And then you might have come across the Stanford Generative Agents paper, which was like a system of 25 agents where each agent was given a different backstory and they interacted in this virtual universe. So we've been really excited by all of this research. Next slide. However, there are some issues with the way that we currently build LLM agent systems. So, and even the creator of Baby AGI has come out and said this in a tweet that you see on the right-hand side. He basically says that what we call multi-agent systems aren't true multi-agent systems because each agent uses the same LLM, the same architecture, the same data, maybe it runs on the same server. So he calls this, more like a single agent with multiple modes, or like a single agent putting on different hats. And, he's starting to think more about true multi-agent systems, which is also what we're interested in at NAPTA. So next slide. Yeah, and there should be advantages to running agents with different LLMs and on different servers because they can use different local data. Just like last week, I think this paper came out, the Internet of Agents, that explores heterogeneity of agents and how that improves performance. So agents that use different architectures, like have access to different local data, different LLMs, all of this sort of stuff. But it's actually super early. And I haven't really seen anything else in the literature about this. And this is what we've been working on for quite a while. They show that, these heterogeneous agents actually get state of the art on the Gaia benchmark, which is like a benchmark recently released by Meta. So yeah, we think this is super exciting. However, there are still some issues with even the Internet of Agents paper in that they use centralized orchestration. In other words, like all of the messages that pass between different heterogeneous agents, they all pass through this like centralized hub, basically. So next slide. There's a bunch of risks with decentralized orchestrators. We've seen it with previous generations of hubs like GitHub and Hugging Face, as well as like previous generations of app stores. So a lot of the time the users don't have ownership. The users find it difficult to monetize. There's a lack of transparency about the data and usage of the platform. Platforms can deplatform the users. We've seen monopolistic practices with AWS. So the question is, do we want, for this next generation of apps and multi-agent systems, do we want to have this like centralized orchestrator that has this power to, kind of take advantage of the ecosystem? Next slide. So as Abhishek mentioned, we actually met at Europe's in 2022 at the first Web3 AI workshop. And in one of the papers that we submitted there, we actually pioneered the concept of the decentralized AI stack and all of the different technologies that you need to put together to be able to run decentralized AI applications. So you need, a registry for services, a registry for artifacts. You need to store the global state of the multi-agent system somewhere. You need to handle the communication. So this is where we first started to map out all of the different pieces of the puzzle and how to put them together. Next slide. And that's what we've put all together into NAPDA. So there's the main thing we focus on is decentralized orchestration of agents. We do this using a combination of off-chain and on-chain message queues and databases. Inspired by previous generation of orchestration tools like Kubeflow pipelines and even like LangChain and Langsmith, but we're the first to do orchestration in a decentralized way. We're also working on decentralized registries for the different modules that run on this platform. So we've modified Baby AGI so that each agent runs on a different node. We're also working on the Stanford Generative Agents paper, where each agent runs on a different node. And hopefully that's going to allow us to scale to more than 25 agents, maybe like hundreds of agents or thousands of agents, or eventually millions or billions of agents. And there's some different parts of our stack. We've built NAPDA nodes for running agents locally. We have an SDK for prototyping different multi-agent workflows. And then, as I mentioned, we have all of the platform stuff that does the orchestration and the registries. Next slide. So yeah, that's it. I think I'm a little bit over the 5 minutes. But yeah, it's been fun to listen to all of the people working on decentralized AI and looking forward to discussing on the panel.
Very exciting. Billions of agents, Internet of Agents. I think it's all coming together. Okay, next we have Sri Satish Ambati. Do you want to share your screen or present?
Well, thank you for having me. It's fascinating to see all the projects here. Let me pull up kind of our latest agent. I was just checking up one hour while I was at it. Thank you for what I user-owned is the way to go. Right?
We can't hear you.
Let me.
Your audio is too weak, Sri.
Is the audio weak? Sorry.
Yeah.
Any better, or is it still the same?
I don't know.
Yes, better.
So let me kick off probably a demo. How should I think we democratize AI, and that's been the core mission for the company with personal LLMs on the edge. And I'm sure you've asked these questions before. Let's say we actually believe that all LLMs belong to the. I actually quite well agree with the user-owned mindset, right? And I think the way I would typically demo this thing is you go completely offline and see what's state of art on the local device, right? So I think to a large degree the on-device LLM movement is here to stay. And I think to some degree, I think some of the speakers already touched on it. The data is actually kind of the where the rubber meets the road. We spend a fraction of the cost, about $35,000, to build some of these models. So the cost of building the LLM, then obviously serving the LLM and using AI to kind of tweak and train as well as clean the data. I think so. Data cleaning processes. I think in general, beginning to see definite orders of magnitude scale.
Your voice speak again, Sri.
Beginning to see kind of the way to kind of build these models and create a way to orchestrate them. Obviously, we do, if you will, we continuously compare and contrast these models for price, for latency, and accuracy. So I think this is something that the team is constantly testing and rebuilding. And I think one of the things that we're beginning to see is users are beginning to give their own REST endpoints for using an API that can then plug in and so questions and answers, but also beyond question and answers, start powering applications, which is kind of the way ahead. So applications. So I would say in at the heart of what this is actually trying to get inferences into a trusted framework of models, both AI models. Open source is how we chose much of how we did our democratization, and I think there's a race on for the Gaia benchmark, which got mentioned on AGI, and I think agents are beginning to be a very strong force. Our core focus being our customer base. We've been obsessed with our customers over the last better part of the last decade, and acquiring some incredible talent globally. This talent is really obsessed with solving problems. I think customers such as payroll companies, some of them you might have been using, like ADP and others, have an incredible amount of data. They don't have, they have inference endpoints that they can serve their customers. So what we've been making happen in the completely enterprise B2B, B2B2C network framework is to create inference marketplaces that can be used for personal benefits. And I think a natural extension of this is along the lines of what both Chris and Juana were talking about, which is how do you bring a much more user-owned nature to it and bring network of scale. So I think that's, I mean, I think we don't want to, but I think that the applications is kind of where the rubber meets the road. But a lot of our customers are beginning to buy into how you can, when Hugging Face models are out there, but how do you validate they are still the most effective ways of using your models? And I think what we're doing with our frameworks is the ability to take these LLMs that are reasonably world class at this point compared to V or Gemma and Apple's models, and create the same framework. So when someone like one of our customers in the bank or in pharma want to build their own LLMs, we have a framework that allows them to build at a fraction of the cost, and the cost per query for. And I think it'd be a wonderful thing to. I mean, I'm a huge fan that users own their data. We just parked. It's kind of like you parked your data in a parking lot, and now the garage owner decides to own your data, right? Sort of, I think a complete data ownership is a civil right. So I think our mission to that has been through open source. I think the next generation of platforms will absolutely be can take advantage of the frameworks we built, like LLM Studios and others, mostly in open source. 90% of what we do is open source, and we're a free, sustainable company at this point. So our models like Danube are being deployed across several frameworks. So it'd be awesome to see the next generation of decentralized companies collaborate, and hopefully we can promote your work with the monetization. The B2C of AI, which is ChatGPT in some sense, has driven incredible attention to the space. But I think the B2B part of it, or B2B2C and B2B2G, we're working a lot of the governments, like the Department of Treasuries, OCC, and others to build trust around models. And I think it'd be fun to kind of be a channel for the startup community here to some of the customer community we already serve.
That's amazing, and love the demo, and always good to see customer adoption. And I love also your parking slot analogy. So we'll take the questions during the panel session. Next, we have Thomason. Stage is all yours. Feel free to share the slides.
All right, thank you very much. And thank you to Dr. Ramesh and also the entire team for putting this together. Please let me know if you can't see the screen. We should be able to see it now.
You can see it, yeah.
All right, perfect. Hi, everyone. I'm Thomason. I'm the founder of Tivana Labs, and we're building HiveNetwork.ai, which is a peer-to-peer AI protocol. So we're building with the same tenets and vision to decentralize AI. So while that's a huge vision, we're going to start from a very specific product. So today what you have is that as developers, you build an AI agent, and now you need to figure out how do you actually get to market. but devs don't sell, we don't do marketing, we don't do community building by nature. So what this means is that it's very difficult for those who would use your agents, your customers, to discover you. So we're building that all in one marketplace that has all the AI agents on there. So what we do is that for you, the developer, we give you the simple agent workflow builder. So just drag and drop UIs, or even the SDK that is already open source. And these have payment solutions integrated into them. So both fiat and crypto. Then for your customers, they have the ability to actually find your agents just with natural language search. And even the agents can compete or collaborate to produce results. So let's have a quick look at a demo. So here, you can see the marketplace. So think of it in a way almost like an app store of multiple AI agents at your disposal. So your customer has the ability to go in and choose any AI agent they want in any vertical. But to actually build an agent, you don't even need to be a developer anymore. What you can actually do is go in, specify the details, enter the system prompt, put in some descriptions about your agents, and you can actually go ahead and set a price. So setting a price on the marketplace allows people to actually figure out how much they want to, what they value your agent at and how much they'll be able to pay to use it. So here we developed a custom tool with one of our partners, LivePeer, the largest decentralized video platform today. And now you can see as the agent has been built, it's already available. So now we can actually go ahead and build a swarm. So agents are powerful with their models and tools, but you can combine them to create swarms. A swarm is where you have this orchestration of agents, and you can dictate what each agent's role is in this swarm. So we're building that communication protocol for agent-to-agent interaction. So very quickly, let's see what it's like to use that agent that we built earlier. So you can just start a new chat, similar with your ChatGPT experience. Go ahead, and in this case, we can fast forward, but basically, we're just trying to ask it to generate an image for us. And, you send the prompt and get the response shortly afterwards. So, just something, just a funny picture. But essentially, even that, depicts the idea of where things are moving. In order to truly democratize this, you also need to make it easy for anybody to build, not just the developers. So we do give you the SDK, but also the workflow builder. So about the team, I'm a former senior blockchain engineer at PayPal on PayPal Crypto. ChainML, who's also a decentralized AI company. I was previously on the team that built Canada's largest blockchain network. So it's used by the major Canadian banks and the Canadian government, serving millions of Canadians. Our team is full of talented engineers and also marketers. So this is our partner network. But to fast forward this, because we're already in the AI space, we all know that the killer app was really ChatGPT, right? At the end of the day, it took 5 days to reach 1 million users. And right now, there tends to be a lot of confusion around, what exactly is the application layer. There's assistants, there's co-pilots, and there's agents. We are focused on the agents, right? Because agents are meant to be more autonomous. An assistant is something that you have to be there to work with it, right? It's time consuming, but all of these call back to a model, usually a generative AI model at the end of the day. So what is an agent? Right, it's a goal-driven program that interacts with its environment. It can make decisions and take actions, right? And it's usually autonomous. So it has a goal. There's a planner, usually an LLM that it uses. Then it has a bunch of tools. We saw where we used a text-to-image tool in our agent. And of course, it has memory. So the high-level architecture is going to be a peer-to-peer network where you have the agents communicating with each other. They can interact with any blockchain they want, EVM, non-EVM. Then they can call out to any API services. So inference servers, whether it's a decentralized inference network or even a centralized inference network. So speaking of decentralization, what exactly is decentralized AI? The best way, to really think about it is it's an approach to artificial intelligence that distributes the data processing and the computational tasks across multiple devices. so that we can enhance privacy, security, and scalability, and reduce that reliance on central authority. So what does that, what does it now look like? So the base layer, you need all these GPUs around the world. You need a heterogeneous network of GPUs. People would have different GPU, qualities or grades, basically. So you need all of these nodes to be connected to each other. Then you have this knowledge layer where you have the data. So not just data sets for training, but also context data that can be used for RAG. And then you have the models side by side. Then, as we've seen, is the application layer. So what we're focused on today is building out that agents network. And the key enabling technologies for this, definitely blockchain technology. You need a very good way to verify the work that has been done. So you need a good consensus mechanism, verifiable computation. So whether it's zero knowledge proofs or trusted execution environments. Then, of course, private data computation with fully homomorphic encryption, and of course, the computes. So some of the challenges with decentralized AI will be scalability, smart contract risks, as we've seen lots of times in crypto. The cost of verifications can be very high with zero knowledge proofs, data quality and authenticity, hardware risks, and also over-regulation, from the legal side of things. So that's everything about us. If you'd like to learn more, please go ahead and scan the QR code. We have more demos available on there, or you can just visit our link tree at linktree/hivenetwork.ai. Thank you.
Incredible. Awesome presentation. So now we will put all the panelists on the screen. Let's see, how do we do that? Okay. And. Okay, we have two now. Now I'm gonna add Rich and okay. Chris, on your end, just to confirm, you can see all four panelists, is that correct?
Yep.
Perfect. Okay, there you go. So I think audience has some questions, and I saw Anna, you're already answering them. So we might put a few of them also. But before we go there with the audience questions, I also had a few questions. To get started, we'll go in the reverse order of the way people presented, and starting with you, Thomason. So the question, actually, one of my question was, there are three terms which are being floated around: agents, co-pilot, assistant, and you already answered that. But in this decentralized AI domain, how do you think these three things are playing out? Is there any other factor in addition to the autonomy dimension you mentioned?
Yeah, so it's also going to come down to the capabilities, like the kind of tools that are available. You could give assistants some more tools, but at the end of the day, you have to be there to use the assistants, even to use the co-pilots. But an agent has the ability to, do longer running tasks, right? So you could set up a server that just runs, as long as the task needs to be done, and then continues to answer questions. So, the agents could be responsive, or it could be proactive, looking for opportunities. So if it's a crypto, if you have some agent that needs to watch out for liquidations, on a platform like Aave or Compound for DeFi lending. So you could have agents that are actively seeking actions to take, or they're waiting for instructions. So, it does tie back to autonomy, but, when you talk about decentralization, it's really where those agents are going to run. Are they going to run on AWS, or are they going to run on, decentralized compute like the Cash, or in a, more Bitcoin style way where everybody is able to run it on their own devices.
Perfect. So continuing that trail of on-device, Sri, question for you. So right now, the agents can, or not agents, but people can use these models which are available open source, run it locally. How are you thinking about training or even fine-tuning of these models so that it becomes more personalized for their preference and previous chat history and so on?
No, that's a good question. For a long time, I think customers were a bit, when I say long time, it's 12 months old, right? So 16 months ago, Bloomberg tried to do their own model and ended up spending much larger price tag than they would do today. I think the cost for building the fine tuning, so RAGs came about, you didn't need to do a lot of fine tuning, right? So I think the cost for a model has dramatically reduced even from then to now. A lot of the lessons from the open source world, right? Starting with Llama CBP to Mistral to Danube and all other models now. Things have really gotten a bit more mature. Customers are a bit more capable of using frameworks like LLM studios. We have an open source studio that is being, but again, DPO versus, RLHF was people took that route and found difficulty. I think using the ability to create their own, and I think the 3.1 paper kind of lays out some of the tools we built for our customers as well, which is how to use LLMs to do data quality, kind of how do you chop a large document to question answer pairs and create more evals. I think the evals that are out there publicly, many of the benchmarks have been have broken under the pressure of competition, if you will, right? So they're building those benchmarks that you want to have for a good bank teller or a good or a decent assistant to augment your teller or a decent assistant to augment different functions. I think all of that evals, so building a strong eval framework, LLM framework, LLM studios that can fine tune at a fraction of the cost. One thing that the clouds are beginning to realize that failed experiments produce dollars as well as successful experiments, right? So I think try to reduce the cost of failure as well as making sure cost of fine tuning these models. We're working very closely with customers, training them as much as co-creating with them. But I think it becomes eventually, once it becomes a table, like kind of standard kind of part of curriculum for any graduating MIT student to build his own model for his own data and hopefully using something like Wana or other on their own. I mean, our model runs on the phone. It belongs to the user as well, right? So in that sense, it's the beginning seed. It does good English. So now let's let it learn more about each person, both the personal LM, a professional LM, and a universal LM, what you think about the news of the world, how you curate it. I think all three frameworks will probably start emerging. And I think how do they store it, manage it? How do they curate it? How do they keep it up to date? All of that, the kind of the my GPT, my LLM world is going to be the. It's not that far from fruitioning. So I think
the one interesting point here, which you mentioned initially, is about the cost is going down for these models, and also the need for fine tuning might not be as much given that context window is increasing. We have improved in RAGs, and perhaps we don't have to change the model weights. We just have to fit more information in the context window, basically, right?
Retrieval is still a retrieval chunking of the semantic chunking of the documents, right? Then starting to use images, video, audio, right? We kind of still look at transcripts as a way to, and if someone took a transcript of this particular meeting, I think the multi-user, multi-human meetings, it's actually getting the audio powered LLM. So I think the 3.1 paper kind of lays out how to bring in different we're doing a multi-model as well for strictly for documents on OCR. I think especially for home mortgages, right? Or certifying who owns what properties, right? All of that traditional things that needed a human notary to go to, which was actually what digital ledgers were supposed to have solved. We got sidetracked in the traditional coin world. I think now if you bring AI is a killer app for a lot of things. AI is a killer app for blockchain as well. And I think that's and the AI on the edge is actually going to be even more fun because phones are not getting any smaller; they're getting more powerful. The part we haven't yet cracked the code on, and we're beginning to try that with one of our partners, Samsung, is trying to see if we can get multi on the edge models to start working as a group, as a collaborative agent framework. And I think that we haven't yet, when we're barely beginning to figure out how humans can collaborate. I think the agents, social network of agents, is going to be quite how they negotiate, what protocols they use to come to a consensus. All of
Perfect.
these are
So that argument brings us to Rich. Collaboration between agents and this like paper also Internet of Agents, and one of your criticism was its centralized orchestration. Another point you mentioned, which I would love to hear more from you, is that you should have multiple models and you should not be using just single model, and that model is representing multiple agents. So what's the underlying reason? And also if you can share more of your thoughts on the communication paradigm, because I think it's going to be very important how they communicate, collaborate, and exchange information.
Yeah, sure. I think, yeah, I guess like why would more different LLMs be good? In the same reason that with humans, if you have different humans with different like skill sets, different backgrounds, that tends to be more effective for a team, right? So we have this kind of wisdom of the crowd effect that happens with humans, and we should probably see the same thing with LLMs. And it's kind of understandable that we haven't seen much research on this up until now, because everyone has used like one or two LLMs up until very recently. But now we're starting to see more and more open source models emerge. For the first time, we have an open source model that seems to beat some of the closed models. So I'm really excited to see all of the variants of that, all of the fine tunes, all of that sort of stuff. So I think we're very close to being in a world where we have many models that are quite powerful. And so we're just about to start the experimentation to see what happens if we connect them together and allow them to have debate, or to organize in different types of workflows and that sort of thing. So yeah, I think if I was doing research, like well, we are doing some research, but if I was a researcher in MIT, I would definitely be diving into some of this stuff. So yeah, that's kind of the motivation behind why different LLMs should be better. And then the question is like how to achieve that from a technical perspective. And we're just starting to explore that really. A lot of people have LLMs running locally on their laptops now, using Olama or like LM Studio, Super AGI, different frameworks like this. But like at least I haven't seen anyone that connects these different LLMs running locally together. So it's a little bit challenging with like stuff like laptops. We're using many different approaches. So like one approach is, well, if you're on a cloud server, you can just, you have a public IP address, so you can just kind of ping that IP address and maybe have like a REST API or a WebSocket or something like that. For laptops and that sort of thing, it's a little bit harder because usually they're behind, a router, a Wi-Fi router or something like that. So we're actually using like relay servers in that case. So like a laptop can connect to a publicly available IP address, and then that will route messages through. There's a bunch of crypto projects working on this. Like one cool project that we've got a lot of inspiration from is like Kinode, Kinode. They're kind of providing this like infrastructure just for communications. Also, Fetch AI built the ACN, Agent Communication Network. That's open source. You can use that as well. So there's a bunch of like technologies to build on to connect these different agents. But in general, I don't think it's going to be any one type of communication protocol. I think we should allow for many different types of communication protocols, whether it's WebSockets or TCP or like a bunch of different communication protocols. So I think we should be able to use. We should give agents access to use many different types.
Yeah, and hopefully there'll be a similar vertical stack of how we have this TCP IP stack where you have a network layer, you have TCP IP layer, application layer, and so on. So Anna, I think you already got lots of questions on Zoom, and one particular question from Zayed Tasneem, which I'm also curious about, wanting to know. So the question is, what are the key trade-offs of selling data from these user-owned data silos compared to training models on these silos and selling the model instead? And I would add one more thing, which is selling the inference from these models, which are trained on these user data.
Yeah, that's a great question. We sort of distinguish between renting your data and selling your data. So if you're renting your data, you're just allowing for a specific operation like model training to happen on your data. And what that does is it kind of aligns the economics a little bit better, where you can earn based on, like, if you've contributed your data to an AI model, then you earn every time inference is run, right? And so that's sort of like the ideal case. And actually the Reddit data DAO, the way they trained their user-owned AI model was just renting the data. And so the model weights are stored securely in the system, and people have to essentially make a payment to all the data contributors each time that model is used. Some of it's batched up just to make it a little more efficient. But there are cases where someone wants to actually get a copy of the data for certain use cases. So for example, there is like a platform that's working on building a new version of Reddit that's more focused on user ownership. They want to use the Reddit data set to kind of seed content on their platform. In that case, you do actually need a copy of at least a subset of the data. And so it sort of is up to the data collective to decide. We strongly encourage renting whenever possible, or if you're selling, only sell certain pieces of the data or sell subsets of it. Because with any data marketplace, you have what we call like the double spend problem for data, right? Where like if you sold someone your data, like they could sell it again, right? So renting really controls the economics. And that I think is kind of the best method. But I think because it's so early in the decentralized AI space, there are cases where someone wants to sell a copy of it. And so the system does allow for that when it's needed.
I just wanted to jump in and ask if you've seen the paper on information markets. It's called like Information Bazaar. It's a really good one, which, when we're sharing access to information, we have this issue that we want to convince the user that it's, this information is worthwhile. But then once you give them that information, then they have it and they don't need to pay for it anymore. So what this information markets paper, it's called Information Bazaar, did, you allow access to the information for your LLM or your LLM agent. And then that LLM agent can kind of evaluate it and then also like forget the content of the information. So there's still some really exciting developments coming out in that space.
Yeah, I think it's really powerful. Like if you imagine an agent which is trained on like everything you know, right? Like, okay, I'll just have like 5 AI Annas who like exist autonomously in the world and like do work and earn revenue, et cetera, right? Like I don't want someone to just randomly copy those model weights, right? That's like clearly much, then I've like lost my ability to monetize it. So I think those sorts of paradigms where you're basically protecting the privacy of the data or the model weights is so important in order to make sure that you're kind of maintaining true control.
Awesome. So we are running out of time. So let's wrap this panel up, and hopefully we can take a lot of these questions and discussion offline.
I was going to riff off on just one topic on that theme, which is synthetic data, right? Sort of being able to mimic your data in a way that's not personal, but very structurally similar, and how you can amplify the signal on that front. And I mean, the whole concept of allowing you API access to your data for fighting Alzheimer's, but not for a political cause. I think those are the kind of things that policies and how do you enforce those policies become really quite fascinating.
Yeah, I think there's going to be a whole access control layer, which probably has to be built similar to how in early 2000s there was access control for just data control, encryption, and so on.
Fantastic.
So, you want to go ahead?
Yeah, let's thank our panelists one more time. Thus, we have hundreds of folks online right now. So thank you all for joining. And just to wrap up, I want to thank the organizers and also remind everybody about our Decentralized AI program. If you're interested in the membership for the MIT program Decentralized AI, send us an email to the email address shown at the top, raskar@mit.edu. And we really think this is a whole new world to see how we're going to think about AI. Using the analogy of a computer versus the internet back in the 80s, it was not enough to have just computers or even distributed compute to really make the revolution. Internet has been around since 60s and 70s, but the concept of web came around only in the early 90s. So you want to make a transition from internet to the web required a lot of efforts, and MIT, as usual, was at the forefront of it through the World Wide Web Consortium that's based here at MIT. And even today, World Wide Web Consortium really sets all the standards, all the research on encryption, on privacy, on efficiency, global registries, and so on. And much of the discussion we're having today also requires a similar, very organized effort. And we are just delighted that some of our colleagues at MIT are participating in this effort. But clearly, it's not going to be MIT-centric. We need, the large village here to work together. So yeah, please join our consortium. Send us an email if you want to become a membership. Different levels of memberships, whether you're a corporation or a startup or an individual. So look forward to working with you. And I want to thank everybody for participating. And we'll see you very soon in our next session in early September. Thank you.
Thank you.
Ramesh, please show the WhatsApp QR.
We're going to stop the official recording. And we can have a chit chat if people want to stay on.